Today we are doing 142 minimum number of days to make m bouquets. We are given integer a bloom day and integer m and integer k. We want to make m bouquets. To make a bouquet we use k adjacent flowers from the garden. The garden consists of n flowers. Each flower will bloom in the bloom day I that can be used in exactly one bouquet. Minimum number of days you need to be able to make m bouquets from the garden. If it is impossible to make m bouquets, return -1. So what I'm thinking is that if we can make the bouquet in 10 days, we can also make it in 12 days, 11, 13, 14, 15, so binary search. Now, how do we check if we can make it in n days, right? Well, we get like continuous subarrays of flowers which we can use, right? So for example, after day 3 we have 3 arrays. Now for each such subarray we need to use k adjacent flowers, so that means that from each such subarray, if its size is like x, we can use x floor k, x divided by k floored, and we calculate this over all the subarrays, sum it together, and if it's at least m, then we can do it, and we set left border to L or R border to M, and if we cannot do it, we set L to M+1. And question is, what is max day? Max day is 10 to 9, so we are gonna do like n log max solution, and we don't really care about k or m, I guess. Not sure if we can make a linear solution. I mean, I don't know, tough to say, and Slovak keyboard, bloom day, and then we go. What do we do here? LR0 max. What can the days be? 1 to 10, I guess. And all numbers are at least 1. Okay, so we do this. Okay, and then we do like right, left, right, right. Okay, and then we go P1, P2, 0, 0, while then P2, P1, while P2 less than N, and okay, so if bloom day P1 over meet, otherwise we do this, and bloom P2 is less than or equal to meet, then and then we do can make is 0, and then can make plus equals P2 minus P1 divided by K, Now if we can make at least m of them, then R is m, else L is m plus 1, and this is some sort of check, I guess so. Can meet, so what I can do is def can meet return can make, or let's do this, can make, and we return can and then return L if can, else minus 1. What the hell? I mean, can is right here, bruv. What is that? I mean, that should work. Oh. Okay. Didn't quite work. That's weird. Print meet can. Okay. Should pass. I kind of smell that we need to do a linear solution, but I don't have time for that, so let's check. Oh, there's nothing. Okay, so I just have a bad implementation. Let's go. Okay, well then I don't care. Why can't I write solutions sometimes? Let's see, binary search O and look max. If we can make the bouquets, is this how you write it? Bouquets in m days, we can make them in m plus 1, m plus 2, blah 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 days. How can we check if we can make the bouquets in m days? We simply find the subarrays of flowers which have bloom day and how many bouquets can we make from each subarray if its length base L, we can make floor LK bouquets. Just find the subarrays by iterating over bloom day until we encounter flower for which bloom day flower over M, and if we can make the required, if we can make that's number of bouquets in B base. Make the M in mid days, mid, since we want to find the lowest number of days, otherwise we set n log max each of the iteration takes on. Space complexity 01, since we only use a couple of, don't think we use anything extra. Nah. Okay. Goodbye.